In this video, you and me, we're gonna get real serializable together. This is, of course, a small taste of the material that I have in my T-SQL course. 23 hours of beginner content is all available now. It's still at the pre-sale price of $250. That will double in value to $500 when the course is done. So, as usual, your job is to save 250 bucks and buy that thing now before you regret it later. You have to give me 500 bucks. Then I light a cigar with it and walk away laughing in my fur coat or something. I don't know, whatever. Leave me alone. So we're gonna talk about serializable because a lot of developers have this weird view of isolation levels that they really isolate everything, and that's still not exactly true even with serializable. Serializable does come kind of close because it forces read queries to take and hold shared locks on data. And it may even take either a lock on a key if you're using an equality predicate, or a range of keys if you are searching for like a range of values, right? Like between, greater than, less than, all those rangy things. Serializable does prevent you with what most people would call an unchanging view of data. It is still not necessary. It is still not a snapshot of the data within a transaction. Different. What I'm going to show you today is different queries within the same transaction, seeing data from different points in time. What serializable doesn't guarantee is particularly when that view of the data started. All you know is that is how the data looked when the query finished. That might be good enough for you. If it's not, you might need to look at the snapshot isolation level. Read committed snapshot isolation does also come reasonably close to that, but snapshot isolation is the snapshotiest, especially if you need transaction level consistency and not just statement level consistency. That's pretty much a place where read committed snapshot isolation and snapshot isolation differ, but we'll talk about that more in depth later. The view of data that serializable provides is not necessarily from when a transaction began, especially if the query was blocked, and that's what we're going to look at in these demos here. So what I'm going to do is just drop a table, create it, and stick 11 rows in it. You can see here that we have, if Zoomit will cooperate, we have the odd numbers from 1 through 11 put into this table called Serialize, which is one of the best bars in Boston. In case you're wondering where the name came from. It's getting towards the end of the day here. All right, so let's make sure there's no weird open transactions in here, and we're gonna run through these demos in two different ways. The first way I'm going to run this is, we actually need to switch this back to 7, is we're going to start a transaction, we're going to set the isolation level to serializable, and then we're just going to run a select from that query where ID equals 7. Now this table does have a primary key on the ID column, so we don't we can just seek right to whatever we care about. We're not scanning pages or locking the table or anything. So let's run this and let's grab ID 7. We get that very easily, right? But now we have this transaction, and serializable has taken a lock, right? It's going to hold this shared lock on ID 7. If we come over here, what we're going to find is that we are still allowed to insert ID 8 into the table, right? So we can put ID 8 in because serializable doesn't need a lock to make sure that ID 8 doesn't change. But now if we come over here and we try to run this select query is going to get blocked, because this select query is looking for where ID is less than or equal to 11. Remember, 11 was the last key in our table, so it's essentially just looking for everything behind 11. This query is now blocked because this, and this would happen under read committed as well. This query would get blocked because this insert has an open transaction and it's holding a lock on ID 8, so we can't read that row while we're doing this. But if we run this insert, right, we do this, and this all finally commits. What I think surprises a lot of people is that the serializable transaction with two select queries in it that ran at two different points in time essentially saw two different views of the data, right? So like this thing ran and it found ID 7. That's not really all that weird. But what people find weird is that when we run this query to look for where everything where ID is less than or equal to 11, not only does this query see the ID 8 that we inserted, but also the ID 11, the ID 10 that we inserted, the even numbers, not the odd numbers. So this is what kind of freaks people out, because like they're expecting this, unchanging, like consistent snapshotty view of data, which is not what serializable provides. Again, it's only what the data looked like when the query finished. Like when that query began, or any locks that it ran into along the way can certainly interfere with that. So let's make sure that we don't have anything weird going on here. Make sure this is all fully committed. So when we refresh the table over here, we don't get blocked and get embarrassed by ourselves. So let's do this. Let's start a transaction and insert ID 8 here. Now let's come back over here and let's actually change this query for a little bit of texture. And let's run both select queries. Let's actually, I guess, run the whole thing at once, right? And now we have these two select queries running. This one is blocked, looking for ID 8, because ID 8 is held onto with this one. But now I can run this query, and I can insert ID 10. And like, not only is this query that ran, right? This query that ran up here now found ID 8, because this happened after the lock was released. But this query, once again, saw both 8 and 10. So the main thing here is that, serializable, select queries will take and hold shared locks much, much longer than they will with read committed, the default locking isolation level for all SQL servers except for Azure SQL Database. But serializable will take and hold shared locks, and where read committed doesn't. And what that sometimes leads people down the path of is thinking that there is some internal mechanism scheduling these queries, like queuing them up, like when you see the blog post diagrams of like, here is T1, it is scheduled for now. It's like a train schedule. Here is T2, it is scheduled for now. But that's really not what happens. These queries all run and they attempt to take these locks, but they're all working off the same live table data. There's no snapshot consistent view of this data that's often stored anywhere. So even two select queries in the same transaction can encounter different rows when they run. Again, this might be good enough for you if you even need this high of a level of isolation, but it is still not a snapshot view of the data. And once again, you would still need a row versioning isolation level in order to obtain that. Anyway, that's enough about serializable. You probably don't need it. You probably don't want it. When you use serializable, you certainly prolong blocking operations, especially from read queries, and you very, very certainly increase your likelihood of encountering deadlocks with read queries taking and holding shared locks in ways that are often unfamiliar to people used to working with either read committed, the locking isolation level, or just festooning your queries with no lock hints every which way you go. So I hope you enjoyed yourselves. I hope you understand serializable a little bit better now. And I will see you over in the next video where we still have some ground to cover with the transactions and isolation level stuff. So we'll get to something a little bit less isolating than serializable in the next one. Anyway, thank you for watching.